Hello, today I am going to present my topic on modulation and multiplexing techniques under the subject data communication and networking. My name is Prasanth, and in this presentation I will explain how signals are transmitted efficiently in modern communication systems, especially in wireless technologies like Wi-Fi, LTE and 5G. This presentation will cover modulation techniques, multiplexing methods, multiple access schemes, and duplexing techniques. Let us begin. In modern communication systems, efficient signal transmission is very important. Today, millions of users are connected through mobile networks, internet systems, and wireless devices. If all users try to send data at the same time without any control, there would be interference and communication failure. This is where modulation and multiplexing come into the picture. Modulation allows weak signals to travel long distances by embedding them onto high frequency carrier waves. Multiplexing allows multiple users to share the same communication channel efficiently. These concepts form the foundation of modern wireless systems such as Wi-Fi, LTE and 5G networks. Now let us understand what modulation is. A modulation is the process of embedding a low frequency message signal onto a high frequency carrier wave. In simple words, our original data signal cannot travel long distances efficiently. So we combine it with a carrier signal that has high frequency. During modulation, we modify one of the properties of the carrier signal: amplitude, frequency or phase. This modification allows the signal to propagate over long distances with better strength and stability. An easy analog is this: it is like placing a letter inside a fast moving delivery vehicle. The vehicle helps the letter travel quickly and safely to its destination. Similarly, the carrier wave carries our information. Modulation is extremely important in communication systems. First, it increases transmission range because high frequency waves can travel farther. Second, it reduces antenna size according to the formula lambda equals c divided by f. Wavelength is inversely proportional to frequency. So high frequency means smaller antenna size. Third, it improves signal quality by reducing baseband noise. Fourth, it reduces interference between different signals. Finally, modulation enables multiplexing, which allows multiple signals to share the same medium. Without modulation, practical wireless communication would be physically impossible. Now let us look at the main digital modulation techniques. There are four important techniques: amplitude shift keying known as ASK, frequency shift keying known as FSK, phase shift keying known as PSK, and quadrature amplitude modulation known as QAM. These techniques differ based on which parameter of the carrier signal is modified. In ASK, the amplitude of the carrier signal changes according to binary data. For example, a high amplitude may represent binary 1 and a low amplitude may represent binary 0. ASK is simple to implement but sensitive to noise. In FSK, the frequency of the carrier changes. One frequency represents binary 0 and another frequency represents binary 1. FSK is more resistant to amplitude noise. In PSK, the phase of the carrier signal changes. For example, 0 degrees may represent binary 0 and 180 degrees may represent binary 1. PSK provides better noise resistance compared to ASK and FSK. So, in terms of noise immunity, PSK is better than FSK and FSK is better than ASK. Now, let us discuss QAM, which stands for Quadrature Amplitude Modulation. QAM combines both amplitude and phase variations in the same signal. Because of this combination, QAM can encode multiple bits per symbol. For example, 16 QAM can transmit 4 bits per symbol, and for 64 QAM can transmit 6 bits per symbol. This increases data transmission rate significantly. QAM provides high spectral efficiency and is widely used in Wi-Fi, LTE and 5G systems. However, the trade-off is the higher order QAM is more sensitive to noise. So, QAM represents the evolution of digital modulation toward high. So, QAM represents the evolution of digital modulation toward higher capacity and better bandwidth utilization. Now, let us move to multiplexing. Multiplexing is the technique of combination multiple signals into a signal communication channel. It improves bandwidth utilization and reduces infrastructure cost. It improves bandwidth utilization and reduces infrastructure cost. Instead of using separate channels for each user, multiplexing allows efficient sharing. There are three major types: frequency division multiplexing, time division multiplexing, and orthogonal frequency division multiplexing. In frequency division multiplexing, each user is assigned a separate frequency band. In time division multiplexing, users share the same channel but transmit in different time slots. In orthogonal frequency division multiplexing, the available bandwidth is divided into many orthogonal subcarriers. These subcarriers overlap but don't interfere because they are mathematically orthogonal. OFDM significantly reduces inter-symbol interference and improves performance in high-speed communication systems. That is why OFDM is widely used in LTE and 5G. Multiple access techniques extend multiplexing concepts for multi-user environments. The main types are FDMA, TDMA, OFDMA. These techniques allow multiple users to access the same network simultaneously without conflict. In FDMA, each user is assigned a dedicated frequency band. In TDMA, each user gets a specific time slot. In OFDMA, multiple users share different subcarriers dynamically. OFDMA is highly efficient and forms the backbone of modern LTE and 5G networks. It allows flexible and high capacity communication. Now let us discuss duplexing techniques. Duplexing allows two-way communication. In frequency division duplex, separate frequencies are used for uplink and downlink communication. In time division duplex, the same frequency is used, but transmission and reception occur at different time intervals. FDD generally provides lower latency. TDD provides better spectrum efficiency. TDD provides better spectrum efficiency. The both techniques are used in modern mobile communication systems. To conclude, modulation overcomes distance and noise limitations. Multiplexing improves bandwidth efficiency. Multiple access techniques enable millions of users to connect simultaneously. These technologies form the backbone of modern wireless networks such as Wi-Fi, LTE and 5G. Thank you for your attention. Thank you.